Okay, so let me start with the tutorial on packet tracer. So assuming you have installed packet tracer in your computer, so go to Cisco packet tracer and start this tracer. So we'll see a very simple setup now. I'm going to create two networks, each having one PC connected through to a router. So we'll first start with the routers. So go down to the bottom, click on the routers, and you see several categories of routers. So you'll select 1841. So insert that into the open space here, and then we'll put two PCs. Go to end devices. We'll select a generic PC, put that one over here, click again the generic PC, put that one over here. So we'll give this is just a label. Right now it is PC0. We'll give that an IP address which we will later configure for this PC. We will give it 1.2. So then this PC, well, the reason why I gave 1.2 is, let me show you why. I'm going to connect this, click on connections, click on, now you need to know which cable to choose from, so we will use a crossover cable to connect a PC directly to a router. So click on the PC, select fast Ethernet, and click on the router, select fast Ethernet 0/0, the first available interface. Okay, so we can label this. So this is going to be my 192.168.1.0/24 network. Okay, so the router typically gets the first, like it will get 1.1. That will be the IP address of this interface. Okay, and once we set it up, all right, so like that, I'm going to set up this PC, or I can set up this cable, crossover cable. Click on here, select fast Ethernet, click on here. This is the next interface. So I'm going to put this on 192.168.2.0 network. Okay, so this interface will be 192.168.2.1. So I'm going to label this interface as 192.168.2.2. Okay, all right, so so now let's configure this router through a command line interface. I just double clicked on that. CLI stands for command line interface. So you want to continue with the configuration dialog. Enter no, then press return to get started. So this is called the command prompt. So now type enable to get into the privileged mode. Okay, so if you are in the arrow mode, you are not in the privileged mode. Privileged mode is similar to root access in your Linux systems. So type enable to get into the privileged mode. Okay, then only you can do some configuration changes. So in the privileged mode, as it is in the hash prompt, you can run some commands, as we'll do little later, to display the routing table and things like that. But if you want to do some configuration settings, we have to type config to get into what is called a global configuration mode. Now when you just type config, you see that it is asking whether you want to configure the terminal or the memory or the network, and by default it is terminal. So if you press T, it's going to configure the terminal. You can come out of it, and if you want to enter into configure the terminal, you can also say config space T, config space T, and it will get into the terminal configuration mode. Okay. Now this config mode is like the global configuration mode. So if you want to do any global settings to the router, you can use this mode to change the settings. Okay, so one thing I could do is set host name instead of what it says now. There it says router 0, but I want, that's just a label, so I want to make it kind of set. So once I set host name router 0, you could see that it is becoming router 0 now. Okay, now you can now configure each of these interfaces, right? So we just saw when we selected, this was fast Ethernet 0/0. That's the name for this interface. So we'll try to get into that by telling interface fast Ethernet 0/0. So that gets us into the interface configuration mode. So we are now going to configure this particular interface. And what do I want to configure that? I want to set its IP address of that interface to 192.168.1.1, and the subnet mask is 24 bits, right? So this. Let me see. I think I have to have a space between IP and address. Yes. So there should be a space between IP and address. So IP space address, then the IP address you want to assign for that interface, and the subnet mask. Now you see this is still red in color, so which means the interface is not turned on. So you run a command called no shutdown, no space shutdown, press enter. Now you can see that changed to state to up, so you can see this green line, green color now, to indicate that the interface is turned on. Okay, so we have set this interface, so you can come out of this particular interface mode by entering exit, and now we want to configure we want to configure this interface, the second interface, right? So let's get into that by typing interface fast Ethernet 0/1. The first one was 0/0. This is 0/1. Press enter. And what we want to set? We want to set its IP address. So IP space address 192.168.2.1, and then space 255.255.255.0. Okay, so we have set it. Now you have to turn it on by running no shutdown. So now that interface is turned on. Press enter to get back into the interface configuration mode, and we don't have anything else to do now. We can now exit out of this interface configuration mode, and we can even exit out of the global configuration mode. Press enter. So now if you say show space running config, you can see what all you did. The changes will show up. So you see the fast Ethernet interface 00, its IP address is this, and its subnet mask is this, and 01, its IP address is 2.1, and this is the subnet mask, and so on. Right, so now you can also go to this config, and you can see fast Ethernet 0/0. So whatever you did has been now also it shows up here. You see, for fast Ethernet 0/0, this interface, the IP address is this, and the subnet mask is this. Okay, similarly fast Ethernet 01, this is the IP address, and this is the subnet mask. Okay, So but you should be able to do this through the command line when you show me the demo. Okay, and you should also notice that the port status is on. So if I turn it off, you see that this is turning to red color to indicate that it is turned off. So if you make it click it on, you can change this port to on. Okay, so just now get rid of this by closing this window. So now let's go to the PC, double click on it, go to desktop, and then click on IP configuration. Now you want to statically assign this PC, this interface, an IP address, which is nothing but this IP address. So we want to set this 192.168.1.2. If you press the tab space, automatically the subnet mask gets set up. Now the default gateway is the next hop default router that this PC contacts to send any packet outside of that PC. And the default gateway for this PC is this router, and whose IP address we just set it to be what? 192.168, this interface, right? So it is 1.1. So once you enter it and then press this button, the cross thing, it is set up. You can check by again clicking on it. Now you can do a ping. So click on this command prompt thing, okay, and then type ping 192.168. so you're basically doing a ping onto that router, and you can see you're getting back a reply. Alright, so now let's see if you could ping the other host. Do you think you will get back a reply? The other host was what? 2.2, right? 2.2. You won't get back a reply because we have not completed the settings. Okay. Alright. Now I just noticed that I didn't put it like dot, so it doesn't matter because it's just a label. You can even give it your name or my name. It doesn't matter. Okay. But just to make it kind of easy to visualize. Okay. Alright. Now what matters is what we configure inside. Okay, so let's go to this route, this PC, and now give it the IP address we wanted to give. This is a subnet mask, and for this PC the default gateway is this, whose interface is 192.168.2.1, right? And we click on this. You can go to command prompt and say ping 192. We'll just ping that interface first. That is 2.1, right? So we'll get back a reply. Right? So now let's ping our first host 192.168.1.2. You should get back a reply now. Right? Now why this works now? Because the packet goes from this PC to the router on this interface, and this router, if you click on this and go to the command line interface again. Let's get out of this mode, and press enter. If I say show space IP space route, I should be able to see the routing table at this router. So you see here it is on this interface 192.168.1.0 on this interface 0/0, and it is on this interface fast ethernet 0/1. So let me see if I can make it big. So if I try to send something from this PC to this PC, the packet goes to this router, looks at the destination address, which is 192.168.1.2, and because of the subnet mask, it knows that this host is on this interface. So it forwards the packet to through that interface 0/0, right? So similarly, if I send something from here to 2.2, when the packet gets to the router, it does this bitwise AND of the destination IP address, which is 192.168.2.2 with the subnet mask, and it figures out that that host is in this interface, attached to this interface. Okay, so you should be able to ping from this router ping 192.168.2 from that PC, right? Should be able to ping to this too. Now if you also run the trace route command 192.168.2.2, you will see that the packet first went to 1.1, this router interface, and then went to this PC, and you got back the reply, right? Now let me show you one more thing. You can see in real time how the or in simulation mode, actually what we saw is in real time. So you can see in simulation mode how this thing comes up. Like you can see the actual packets. So click on this plus sign here that says simulation mode, and now then click on edit filters. You can see all those things are selected by default. If you click on this show all none once, everything will get unselected, and then you can click on ICMP alone because you want to run the ping command, which is an ICMP command or uses ICMP packets. Then click somewhere outside, and then click on this thing. This is to show that you want to send a packet. So click on this, and then go to the source PC, and then go to the destination PC. Some color will show up here. Now click on auto capture play. You can see the packet going from that PC to the router, then from the router to, because it's auto capture, so it will play after every some seconds, and then the reply is now coming back. So all those packets are captured here. Okay, so you could click on this packet. You can see that the packet coming from this host, which is 1.2, is having an IP header which is sending from this host 1.2 to 2.2. This is for this echo request. That's the ICMP message type, which is 8, right? And this is the source MAC address and the destination MAC address. So the source MAC address corresponds to this interface, and this destination MAC address corresponds to this interface. Okay, let's see what happens. Alright, and if you look at this, is even more bigger in terms of the packet structure. This is a preamble, and this is the destination MAC address, the same thing we saw here, right? And then the source MAC address. So the preamble is not part of the MAC header, it's just sent for the source and destination to synchronize. And then you have the IP header, IP version 4. The header length doesn't show up here, and then you have the total packet length to be I believe it is 28 bytes. Then the TTL, and then you can see this is a source IP going from 1.2, the destination is 2.2, and this is an ICMP packet, right? So now let's look at this packet going from the router to this PC. Let's look at that packet going from the router to that PC, right? Good. Okay, so you see the packet as is at this router. So let's see what is the content of the packet at this router. So the inbound packet, which came from 1.2 to 2.2, is again what we just saw. The outgoing packet is what is going from this router to this device. As we know from our class that the IP address hasn't changed. The only thing that changes is the MAC address. So previously it came from here to this interface. Now it's going from this interface to this interface. So the MAC address is correspondingly changed. Okay, and still it is what the echo request message, right? So now let's look at what happens when the packet reaches goes from the router to this guy. Actually this is okay, let me click on this. Alright, so this is the incoming packet comes from this router to this PC, and then the outbound is what is going now from the source. This is the echo reply, right? So we'll understand that. I think I can click on this to stop. Let me click on this. Alright, so now you see this is ICMP message type 0. Okay. That's to indicate that is an echo reply. And the source IP address is 2.2 going from this PC to 1.2 to this PC, and these are the source and destination MAC addresses. So going from this interface to this interface, then it is router, right? So now it has to forward from this interface to this interface. Okay, so this is the information at this router. Alright, so now when you click on this guy, you can see what happens. It is receiving it from this. So it's coming from this interface to this interface. So you can check the interface. Let me do that. So let's get out of this for the time being. Let me click on this. If I place the cursor over here, I should be able to see its MAC address. So the MAC address is 009. So if I go back to this, if I run ipconfig, I should be able to see /all. No, it's not working. Okay, so looking for a place where we can see the MAC address. Alright, okay, so this is our MAC address, right, for this interface. So let me put that over here. Okay. This is the MAC address. So let me go to this config. So this is my MAC address. For this interface, right? Alright, now for the other one, which is 0/1, I can look at this interface. Okay, and for this router, click on this. It's not for this one. This is for the PC, right? Okay. This is the MAC address. So now if you do this ping again, right? So let it do once and let it stop. Okay, so now if you look at this, it's sent from the outbound, it is sent from 00009, this is a source MAC address, to 006 and all this 3 dB. This is the destination MAC address, packet coming from this host, okay, at device 192.168.1.2. So now let's look at this packet. This is at this router 0. The incoming packet, you can see, still has the 0009 coming to this interface, but the outgoing packet will go from this 006, this MAC address, to this MAC address 288, right? Still the source and destination IP is the same, 192.168.1.2 going to 192.168.2.2. Now let's do this. Incoming packet at this device is coming from 3D8B to 2AD8, and the outgoing will go from 2AD8 to 3DB. Now the source IP, because this is the outgoing is a reply, right? So that's why it's from 2.22 all the way to 1.2. So if you look at this at the router 0, it's coming from this interface 288 to 3dB, and outgoing is going from this 301 interface to 357B here, okay, and still coming from 2.2 to 1.2. Then if you click on this, this is the packet at this PC that's coming from 3dB. If you look at the details, 301 to this interface from 2.2 to 1.2, and this is the reply packet, okay.